Okay, good morning, everybody. Let's just wait a couple of minutes. You show up, and then we'll talk about. Okay. All right. Let's hit record here. All right. Okay. Good morning, everybody. Let's see how many we got over here today. Okay. All right. So, just want to be sure everybody who's watching the lecture already took exam 3 and checked the grades on Canvas. Okay. You should see 3 grades on Canvas: exam 1, 2, and 3. Uh, the uh, the remaining assignments for the semesters have been posted on Mastering Lab. So hopefully, you guys, there will be no more assignments after what I just posted for you. And we will finish the course next Monday, talking about lecture. And a week from this Wednesday, we'll review for the final. And the final will be the following week, which I will tell you the date and the time and so forth. Okay? All right. So as we're getting close to the end of the semester, it's important to know that I'm not going to extend any more assignments. We gotta wrap things up. I do drop one homework grade, and then I'll average the rest. So by the end of not this weekend, the following weekend, I will average your homework grades, and you should see on Canvas the 3 exam grades and the average of your homework. And then all will be left is your final exam. Okay? All right. So everybody already got a chance to check their grades online. Everybody okay with the grades? Yes?
Yes.
Okay, good. All right. So hopefully everybody has a calculator. So let's go ahead and the remaining part. I need to finish up the very small section on the permutation combination from last week, and then I'll teach you part of the statistics. And then this Wednesday, I will cover normal distribution. Okay. All right. So the counting principle, which is basically is you find the number of arrangements or a number of combinations. So permutation PNR, which is equals to n factorial over n minus r factorial. We use that when what? No repetition and order is important. Combination CNR, we call this CS combination, which we didn't talk about it last week. It's equals to n factorial over n minus r factorial times r factorial. You use that when you have no repetition But order is what? Not important. Okay? So you guys can copy this, and I'm going to give you now some examples of water problems where to use P and when to use R. Okay? And hopefully everybody got a calculator ready. So go ahead and copy these formulas, and I will give you some examples on these to finish up the chapter. Okay? Okay. So now we're going to be dealing with how do I count how many different arrangements I have if I move numbers around, the letters around, people around, CDs around, and so forth. Okay? All right. So let me give you an example. All right. Let's say, okay, not only we need to learn what needs to be done, but you also need to learn what we're doing in this type of situation. Here's a question. How many committees of 3 are there out of 5 people? Okay. All right. So let's understand what this problem wants. I got 5 people. 1, 2, 3, 4, 5. Okay? I'm going to call them names here. Let me call names by alphabets. A, B, C, D, E. Okay. I have 5 people. I need to count how many committees of 3s I can have. I can have A, B, C as one committee, right? Or I can have what? A, B, D as one committee, right? Or I can have what? A, D, E as one committee. Or D, D, E as one committee, right? But here's the deal. Can I call C, B, A as one committee? The answer is no. Why? Because the persons C, B, and A are the same people as what? A, B, C. They're the same people. So I cannot count them twice. Therefore, order is not important. So in this case, I use C to count them. Instead of listing them and counting them, I use C. I have 5 people and I'm taking 3 at a time. And according to the formula that I gave you, it'll be 5 factorial over 5 minus 3, which is what? 2 factorial times 3 factorial. So 5 factorial is 5 times 4 times 3 factorial. 2 factorial is 2 times 1. I'm going to leave 3 factorial. 3 factorial cancel 3 factorials. 5 times 4 is 20 divided by 2 is 10. So what does that mean? I can make 10 committees of 3 out of these 5 people. And we'll use C and not P because I cannot count person A, B, C different than person C, B, A. They're the same people. So order here is not important as long as I get the 3 people. Okay, does that make sense to everybody? Okay, you can go ahead and copy this example. Okay, go ahead. And as you're copying, if you have any questions, just let me know.
Professor, from where we got 3?
3 is this number right here. It'll be this number factorial divided by what? 5 minus 3, which is 2 factorial times this number 3.
Yeah, but why we divide by 3?
What do you mean divide by 3 factorial?
Yeah, why 3?
Well, because see 3 factorial. You mean why did I put 3 factorial here?
Yes.
Because okay, if you don't understand this one, 5 factorial you can write as what? 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. They're going to be canceling out anyway. So why should I write it twice? You understand? I knew there is 3 factorials on the bottom. So I said, instead of writing 5 factorials all the way 5 to 1, I said 5 times 4, and I stopped at 3 factorials so I can cancel it with the denominator. Okay? All right. Okay, can I erase it now?
Yes.
Okay. Here's another example on combination. Let's say, here's a question. How many hands are all spades? All right, pay attention. This is okay. All right. So what are the spades in a deck of cards? The spades are from ace all the way to king, and they're all looking like this. Spades, you know, the black ones. A hand is 5 cards. Always a hand. Whenever I talk about hands, means it's how many cards? 5 cards. So this question is telling you how many different 5 cards are all spades in a deck of cards. So for example, I can say the ace, 2, 3, 4, 5. These are all, that's one of them. Or I can say what? 2, 3, 4, 5, 6. That's 5 cards. All spades. That's another one. Or what? 5, 6, 7, 8, and 9. All spades. That's another one. Or what? 9, 10, jack, queen, king. All spades, another one. Question is, how many different 5 cards are all spades in a deck of cards? Here's the question whether to know whether to use B or C. Will I consider ace 2, 3, 4, 5 different than 5, 4, 3, 2, and an ace of spades? Or are they the same cards? They're the same cards. That means order is not important. So the answer is going to be C. I have 13 spades, and I'm doing what? 5 at a time. So the answer is going to be C, 13, 5. You don't have to write these guys, but you need to understand what my answer should look like. So according to the formula, it's going to be 13 factorial over what? 13 minus 5, which is 8 factorial, times 5 factorial. So let's do that on the calculator. So that way you guys don't have any problem. Okay. So I'm going to go to my calculator and watch what I'm going to do here so everybody understands. This is a little different. Calculator. So I'm going to do 13 factorial. 13 factorial divided by 8 factorial divided by, again, 5 factorial equal. And I get 1,287. So there are 1,287 different 5 cards that are all spades in a deck of cards. So they could be ace to 5 all spades, 2 to 6 all spades, 3 to 7 all spades, and so forth. But I cannot count 1 to 5 spades different than 5 to 1 spades because they are the same cards. That's why order is not important. I want to be sure everybody goes to their calculator and be sure you get this number, 1287. That way I know you know how to use the calculator, guys. If your calculator has parentheses, then you do the multiplication. If not, you have to do division twice. Okay? All right, you can copy this example. You don't have to copy all of this, class. The answer to this is this. I always go the extra mile for you to understand what does my answer mean. Okay? All right, go for it. And I already showed you examples on permutation last time, so we're just going to go ahead now and teach you statistics after this class. But does everybody understand when do we use combination? Everybody okay?
Yes.
Go ahead and copy class and we'll... Okay, can I erase it now?
Yes.
All right. Now we're going to go to a new chapter, statistics. It has 2 big chapters. Okay. So we'll do one today, half Wednesday, and half next Monday, and that will take care of the course. And I'm happy because guess what? We have nothing left in the course. That means we'll finish the course on time. All right. So this is about statistics. Right? Okay, the first thing to do is we need to learn something we call frequency distribution. So what does frequency distribution do? It helps you organize your data. And you really need to know that, especially when you do projects. You don't just throw the data right and let you organize it. For example, let's say you are collecting data about people's salary in the thousands of dollars per year. So some of them are making 30,000. I'm not going to put the zeros here. 32,000 a year, 35,000, 37,000, 40,000, 42,000 a year, 45,000, 49,000, 50,000, 53,000 a year, 57,000 a year, 61,000 a year, 70,000, 71,000, 75, 78, and so forth. Let's say you keep going here. So what you do is, especially when you have large data, what do? You organize your data by something we call frequency distribution. The word frequency means how many times the data is repeated. Data are repeated. So what do you do here? You just make a table. Okay. Here you can put, for example, the salary range, or basically we call it the widths, and here the frequency. For example, let's say I want to do the 30 to 35. What does that mean? How many people make 30,000, 31,000, 32,000, 34, 35,000? So how many? You count. Frequency means you count. 1, 2, 3. So there are 3 people make from what? 30,000 to 35,000. Now I use 36. See here, I went from 30 to 35. I went up by 5. So I got to go out by 5. I have to be consistent. From 30 to 35, now what? 36 to 41, what does that mean? I need to count. Frequency means count how many people. How many people make 36, 37, 38, 39, 40, and 41? So let's see. 37 is one of them. 40 is one of them. That's 2 of them only. Now what I do next? I cannot overlap. I cannot use 41. I'm going to do what? 42 to 47. So how many people make from 42,000 to 47,000? So 1, 2, only 2. Now I do what? How many people make from 48 to 53,000? See, I have to keep the same class widths here. So 50 is one of them. Let's say here, 49 is one of them. 1, 2, 3, 3 of them. Then I do from 54 to 59. There's only one of them. Then I do what? 60 to 65. Just one of them. And so forth. That makes sense? That way, you organize your data instead of throwing it like this. And this is good when you do frequency distribution. It's perfect when you have large data. You have about 300 people. So if you give this to your boss doesn't want to look at each foreign tip. He just kind of looks at this data over here. So are we good, class, with what I just showed you here? Are we good?
The second line, 36 to 41, is 2.
To 41. Yeah.
Yes, but we don't have here 36. So you counted 37 and then 40?
Yeah, exactly. Because I don't have 36. So I just count anything. 36 to 41 means I need to count 36, 37, 38, 39, 40, and 41. So there's only 2 of them that are in those numbers. 36 to 41 means I got to count 36, 37, 38, 39, 40, and 41. There's only 2 of them, which are what? 37 and 40. That's it. I found 42 because 42 is more than 41. I cannot count it over here. Okay, do you understand what I just said? Here I got to count 42 to 47 means I got to count people who make 42,000, 43,000, 44, 45, 46, 47. So I count whichever is available here, I count them. That's what I put over here.
Yes, but 36 is not there.
So, yeah, but okay. But you see, you cannot confuse the people who are watching your project, your presentation. I cannot put 37 here. I have to watch here. I have to put all of them. 30 to 35, 36 to 41, 42 to 47. I have to be consistent. Look, 30 to 35, there's 5 here, 5 here, 5 here. You have, whenever you do your frequency distribution, whether it's there or not, you can confuse the people. You have to be consistent. Even though it's not there, but you still have to put it. So that way people understand that you included everything. See, watch it. 35, 36. See, 41, 42, 47, 48, 53, 54. You have to put all the sequence. You cannot skip. Okay? Does that answer your question, ma'am?
Yes, so even though it's not on the table, the number, but we have to count by 555.
Exact. Actually, there are 6 numbers, not 5 numbers. Watch my fingers. 30, 31, 32, 33, 34, 35. There's 6 numbers because you're including 30 and 35. See? 30, 31, 32, 33, 34, and 35. There's 6 numbers between 30 and 35. Most people, if you tell them how many numbers are there between 2 and 7, including 2 and 7, they think it's 5 numbers, but it's actually 6 numbers. You always have to add 1 after you subtract. Simple math like this, people don't do very well. Okay? All right, go ahead and copy it, class. Now we'll show you something else in a minute. Okay?
They can tell by how wide.
Whenever everybody's done, let me know so I can erase it and teach you different type of statistics here. Okay? Okay, can I erase it now?
Yes.
Okay. All right. The other type of statistics, actually, this topic is going to be called central tendency. Is we call, first of all, let's learn about the mean. Mean means the average. And the symbol is X with a line, which we call it X bar. Okay? So let's start with something easy here. If I ask you find the average of three numbers, let's say 20, 50, and 10, it'll probably be easy. Just add the three numbers and divide by 3, right? Just like you do your class average, right? And when you divide 80 by 3, you get the answer, right? $26.67. That's pretty easy. But sometimes you're going to be getting a table like this. For example, let's say you have this table, salary and frequency. And I'll tell you what that means in a minute. 30,000, 5, 40,000, 6, 80,000, 4. What does that mean here? What does that mean if I have this table that says the salary and the frequency? It means 5 people in this company make 30,000 each. 6 people in this company make what? Each makes what? 40,000. And I have 4 people each make what? 80,000. So whenever we have the salary and the frequency, we call that weighted mean, weighted average. So if I ask you to find the average salary of this company, what would you do? Instead of adding 30,000 5 times, you do what? 5 times 30,000 plus 6 times 40,000 plus 4 times 80,000. Now, what do you divide by? You don't divide by 3, you divide by how many people. You divide by the total frequencies, 5 plus 6 plus 4. So if you go to the calculator, that's 150,000. So if I have 150,000 plus, that's 240,000 plus 320,000. I get 710,000 in the numerator. 5 plus 6 is 11, plus 4 is 15. When I do that, divide by 15, the average salary is $47,333. So this company has 15 employees. The average salary of these employees is about 47,000. So whenever you're given the frequency, instead of adding that 5 times, it's better to multiply the frequency times the salary. This times this, plus this times this, plus this times this, and you divide by what? The total number. The total number is the whole frequency. Most people think it's 3. No, it is, in this case, 50. And we call that the weighted mean. Okay? All right, go ahead and copy your class and let me know if you have any question. So how are we doing so far, class? Are we doing good? Remember, whenever you don't ask a question means I take it you're doing good. All right. Let me know when you're done copying so I can show you another type of center tendency. Okay? So everybody in this class check their grades on Canvas, correct? Just talking to the ones who joined us late, right?
Yes.
Okay. So you should see 3 grades there. And once you guys, and there, as I said, I have posted every single assignment left for this semester. Only thing that's left is the final exam. But by next Monday, we should be done with the course. Okay? Can I erase the board now?
Professor, are you going to post the review
Yeah,
for the final?
Already. Yeah, it's there, but I don't think you guys can see it yet because I want to be sure you finish the homework first. But I already designed it last weekend. Yeah,
Yeah,
Okay.
it is,
I did it.
it is there. I checked.
It's there. Okay, yeah.
Mm.
Yeah. I put everything there. There's no more assignments. The only thing is you're left after this will be just the final exam, which we'll talk about it. Don't ask me about the final yet. I have to check with my department. Okay, just I'll keep you posted on every information I get. For now, you should be done with 3 exams, and not this weekend. The following weekend, I'll start averaging only the homework grade that has my name on them. Okay, and I drop 1 homework grade. Okay, let's say I have 16 homeworks for the semester. I'll drop the lowest ones, and I'll average 15 of them. And then you'll have 4 grade, and then you have the final exam left. Okay? Okay, can I erase the board now?
Yes.
All right. Remember, class, Wednesday we're going to be doing some heavy duty statistics. Okay, so be sure you don't miss the lecture on on Wednesday because yeah, it's something you really need for your future. All right. Okay, the next topic on statistics for this chapter is called sample standard deviation. The symbol is like a little CS like this here. Okay. Okay, first of all, let's understand what it means here. It means how close are the data to the average. That's what standard deviation is. You're not going to see this definition in your book class, okay? All right, for example, let's say I have 5 students in my class and they made these test grades 70, 71, 70, 72, 73, right? If I do the average of these 5 grades, it's going to be maybe about 71 or 72, right? So how close are all of these data to 71 or 72? They're very, very close. That means for sure the standard deviation is going to be almost 0, very small. Why? Because the average is close to all of these. However, if I give you a test grade and students made these grades here, 30, 70, 10, 80, and 100, right? And let's say and another 10. The average here, if you add these up and divide by 6, the bar is 50. So how close is 30 to 50? Oh boy, way too far. 70 to 50, 10 to 50. Since these data are far from it, so you expect the standard deviation to be what? Large. Why? Because the data is way off the average. Now, why do we really need the standard deviation? If you're doing measurements, I like the standard deviation to be almost 0, like 0.001 or 0.1. Why? Because if I ask you to find me the width of my table here, where I have my this here, right? If most of you give me the answer close to each other, and I do the average, say, wow, all of you guys give me answers are very close to average. What does that mean? The answer to the width of the table is correct. But if somebody tells me, oh, the width of this, some of you tell me the width of this table is 5 feet, some says 20 feet, some 30 feet. So the average is going to be what? Way off your data. So what I'm going to say, since the standard deviation is going to be large, I'm going to say, throw the data in the garbage. Go ahead and do it over. So people in the research business use the standard deviation. They like the standard deviation to be very, very small, so that way the measurement will be reliable.
Hey, Professor, the camera kind of
Okay?
blurry.
So does everybody? All right. Okay, is it now better?
No.
No.
I always have these problems. It starts good, and let's see here. Just give me a second. Let's see. Now,
Yes.
Mm.
yes or no?
Never mind. It was, but now it became blurry again. Now it's becoming. Oh, wait. It's like it goes back and forth. So like,
Yeah, it keeps going back and forth.
It's
No.
my Wi-Fi. It's the Wi-Fi.
Yeah, it's blurry again. But it never does it with 0324 though, so I don't know.
How is that now? Still blurry.
now it's clearing up. For now. Now it's clear.
Okay. Okay,
Now it's
go ahead and
blurry again.
All right. So we only have to tell you a few things. So it's okay now. Better.
No.
No.
Well, let's do this. I'm gonna shut it down, go and log back on, okay? Because I really want to, because the calculation to find standard deviation is difficult, and I don't want you to see blurry stuff here, okay? So I'm gonna log off, I'll log back on, and I think normally that takes care of it. So go back in a minute, okay? I'm gonna log off, and then I'm gonna turn it back on, okay? All right, let me.
Yes.
It is better?
Yes.
Okay, good. Go ahead and start copying while waiting for everybody to get in. All right, so you guys can see it better now, everybody?
Yes.
Yes.
Okay. All right. So bottom line is, if the standard deviation is very small, means the data are very close to each other. If the standard deviation is high, means the data is way dispersed. Okay? If you're doing measurements, you like the standard deviation to be very small. Why? Because you like everybody to almost be close to the measurement. Crazy people measuring things and give you answers that are not close to the average. Okay? So this is really just a good example for you to understand what we mean by standard deviation. Now we're going to see how to calculate it. Okay? So how do we find it? So here's how we find the standard deviation. I'm going to give you an example. I have a calculator ready for you. Okay, let's say I have this data here. 20, 30, 70, 90. What do you know about this data? It's not close to each other. So we don't expect the standard deviation to be small. It's got to be maybe like pretty large, right? Okay. So the question is, you should understand what the question is. The sample standard deviation, how much is it? Yeah, I'm going to show you a method different than your book. It's easier than your book, so you don't see symbols. The book uses a lot of sigmas that confuses you. Step one, find the average by adding these numbers and dividing by how many numbers you have. All right, I'm just going to say it's 52. I'm not going to put the decimal here, right? So that's step one. Step two, you make a table. If you follow what I tell you, it's going to be easy. You put the x bar, x minus x bar, absolute value, and I'll tell you these in a minute. The last column is x minus x bar squared. All right. This table will help me find the sample standard deviation. X means the first number, 20. X bar is the average, it's 52. What does this tell you here? X minus X bar, absolute value. Means when you subtract 20 minus 52, if the answer is negative, put it positive. If it's positive, keep it positive. So when I do 20 minus 52, I get negative 32. But I put what? Positive 32. I never use negative. Now, the last column says X minus X bar, absolute value squared. You know what that means? You square the 32. So if I go to my calculator, I'm going to do 32 times 32, and I got 1,024. All right, I'm gonna stop here for a second. Does everyone understand what I did as the first row here?
We can see whole board
Now?
better.
Okay, now I do the second number. I already did 20, now I do the 30. What's the average? 52. What does this say? Subtract these two. If it's positive, you put, if it's negative, you positive. 30 minus 52 gives you negative 22, but I put positive 22. I don't use negative. And the last column, I square 22. 22 times 22. I go to my calculator. I get 484. Okay, how we're doing so far? Are we doing good, class?
In first column, we're just copying the first numbers. In second column, we're dividing by 4, right?
No. This is the average, 52. The second column is always going to be 52. It's the average.
Okay, and then in third column,
You subtract these two numbers, but if it's negative, you put positive. And if it's positive, you keep it positive.
so we subtract from 52, 20.
Very good. And the last column, you square this number, 32 times 32. You got it? Are you
Yes.
good so far?
Yeah.
I'm going to use the third number, 70. Average is 52. 70 minus 52 gives me 18. Now what do? I do 18 times 18. I get 324. Now I do the 90. Average is 52. 90 minus 52 gives me what? 38. What I do over here? 38 times 38. $1,444. All right. So how we're doing so far? How we're doing, class?
Good.
Now you add the results of the last column. Add all the what? X minus X bar squared. Add them all. Only you worry about the last column. So what I'm going to add, 1,024 plus 484 plus 324 plus 1,404. I add them all up. I only worry about the last column. So let's add them up. 1,024 plus 484 plus 324 plus. And I got 3,276. So are we good what I did so far, class? So I only add the last column numbers. Are we good?
Yes.
Yes.
Now I find the number of data minus 1. How many data do I have? 1, 2, 3, 4. So 4 minus 1 gives me what? 3. So if I have 11 numbers here, it'll be 11 minus 1 will be what? 10. Then what I do next? Pay attention, class. Then I divide 3,276 by 3. So I'll go to my calculator. I get 1,092. So let me go back and tell you what I did so far. I added all the last columns. Then I found out how many numbers do I have, took away 1 is 3. Then I divide whatever I added the last column, I divided by the 3, I got 1,092. And my final answer for the standard deviation is, I take the square root of 1,092 and I'll be done. So if I go to the calculator and I do the square root of 1,092, I get 33. It's very large and I expected it to be large, and that will be my standard deviation. Okay, so let's go back and refresh our memory what we did to find the standard deviation, sample standard deviation. Step 1, I found the average of the numbers. Step 2, I make a table where I put the numbers in order. Doesn't have to be in order. Then all the averages. Then what? The absolute value of the number minus the average, and the last column I square that result. So 20 minus 52 is negative 32, but I put 32, 32 times 32. Then what? I add all the last column, and I divide by how many numbers I have minus 1, and I'll take the square root, and that will give me the sample standard deviation. And it's 33, which is large. We expect it to be large because the numbers are not close to each other. See, 20 is far from the average 52. That's why the standard deviation is large. Okay? All right, go ahead and copy it, class. So are we good? Everybody okay so far?
Yes.
Okay. All right, go ahead and copy it. Then we only have to show you the E. I always like to start with the one that's harder. Now we just have left to show you what the mode and the median is, and then we'll be done with the, then we'll start the normal distribution curve on Wednesday. Okay?
Professor, when I went on math lab today, I noticed there were 2 assignments that said El Khatib last assignment, and the other one said El Khatib last assignment copy. Are they both the same thing?
It says, you have 2 of them. Are they duplicate?
Yeah, I don't know. It's like, yes.
I'll check it out. I'm not gonna tell you what it is. I'll look at it after the class is over.
Okay.
How we can do square root in the calculator?
There is a square root key there. What kind of, okay, it's maybe in your do you see x squared key in your calculator? Do you see x squared?
Yeah, x is on top of square.
Behind it should be square root. So maybe you need to put shift then x squared to get the square root.
So I have to put shift and x square and then the number.
Yeah, try it. I don't know. I don't know how your calculator works. Put shift x squared 1092 equal. See if it works. Do you get
No,
33.0 something?
No, it didn't work like that.
Okay, do this then. Do 1092 first. Then second x squared.
It didn't work also.
It didn't work either?
No.
Okay, clear it again. Okay, do you see that square root behind the x squared key?
Yes, I see.
Okay, let's try it one more time. Press second. When you click second function x squared, do you see this symbol of the square root showing up or no?
Yes, I see.
Then put 1092 and then hit the equal. It should work.
This square root has on top of left side x. No, it didn't.
Okay, so what do you mean that there's x outside?
Right here, you root, square root, and 1092. So I have like this on my calculator, square root, but on top of this square, it's
Confuse you.
x.
Do you have a phone with you? Do you have a phone with you?
Yes,
Okay, let's get your phone. Is it an iPhone?
yes.
Okay.
Take a picture
Put-
and send to you.
No. Just it's easy. Just press 1092. Move your iPhone horizontally and see the one that shows. I have iPhone 2. It shows like this. 2 here and X like this, and then you should get 33.
Okay.
Put 1092. Move your iPhone horizontally,
I
okay,
did.
and then put.
Yeah, I got
Okay.
it.
Okay, good.
Thank you.
You. All right, go ahead and copy it. Okay, the one that says copy, okay, you only do a Khatib last assignment, yeah. The one that says copy, forget about it. Okay, I'll send you I'll put that on the announcement for you. Okay, I see. So somebody sent me a picture of it. I'll take a look at it. All right. So did you guys finish to copy the board? Are you all done?
Yes.
All right. And the last things are super easy. How do you find the median? Oh, I have to teach you actually two things here. What do you mean by the median? Median basically is the middle number, right? So I have numbers, let's say 15, 10, 17, 11, and 5. What will be the median? So you put the numbers first from smallest to largest, and the median is gonna be the middle number. And if you have two medians, you add them up and you divide by 2. This is really, really simple. Okay? So you guys, okay. And the mode will be the one that is repeated the most. So if I have numbers 30, 20, 20, 20, 80, the mode is the one with the most frequency. It'll be 20 in this case. Why? Because it's repeated the most. So these are things I shouldn't even teach you. This so super easy, but just in case you want to know that. Okay? So now all we have left is something we call stem and leaf plot. So we'll go ahead and copy this one here since it's easy, but you probably, okay? And that's all we have left for this chapter before, let's go ahead and copy it, and then we'll go from there. Okay. The last thing is something you need to know how to organize your data. We call it stem and leaf plot. So let's say you're collecting data and you're doing a research, and you have data like this: 20, 21, 21, 25, 27, 30, 37, 38, 40, 45, 48, 49, 57, 58. So a good way to organize this data is you make something we call stem and leaf plot. You put the stem on the left and leaf on the right. Okay? So on the stem, you put the tens, and on the leaf, you put the ones. For example, the 20s: 20, 20, 21, 21, 25, 27. I did the 20s, let's do the 30s. So I put the 30s here, then what? I have 30, 37, 38. Then I do the 40s: 40, 45, 48, 49. Then the 50s. See? This is much better way of organizing your data than throwing it like this. But if you're doing the research paper, you need to tell people what you mean by it. So, for example, if you put something like this, say, you know, this means 21, so they understand the stem and leaf plot. Not everybody understands it. So if I have a data with the hundreds, let's say 112, 115, 117, 127, 128, 130, 135, 137. To do the stem and leaf plot, you cannot put one digit on each. Like here, you put 112, 115, 117. Here, the 120s, 27, 28. The 30s, 30, 35, 37. So this is a good way to organize your data, where you put the tens in one column and the ones on the right column. See? 20, 21, 21, 25, 27. That's what we call stem and leaf plots. Do you understand it, class? Are we good?
Yes.
Yes.
It's very easy, really simple. And you know, if you do Excel, guys, you don't have to, like, if you have a bunch of data, you can go to Excel, go to YouTube, says, how do I design Excel stem and leaf on Excel? And you just put the data in, highlight it, and click stem and leaf, and it'll put it beautifully for you. These are really good ways to learn how to organize your data, to do presentations, you know, at your job, or presentation in your course for research paper, whatever the case may be. They're available. And people would rather look at something organized like this than throw in a bunch of numbers like that. Okay? All right, class, that takes care of today's lecture. Any questions?
Can we copy it?
Yeah, of course. Copy it. Wednesday, very important day, Wednesday. It's going to be something I'm going to teach you how to read the charts. Okay? So Wednesday and next Monday, we have 2 more days to learn a new material. And then we will be done with the whole course. And I'm sure you guys will be happy. And I will be happy. But you guys have been very good. You guys have hung in there with all of the freeze and the crazy days and the corona. You still came to class, asked questions, and learned the course well. Okay, copy it. After you copy it, you don't have any questions, have a good day, and I'll see you on Wednesday. Okay? And stay tuned for your announcement. I want to see which I duplicated one assignment. I'm going to delete one of them. Okay?